Second example I want to show you here is how much heat is released in the condensing of 125 grams of steam at 120 degrees Celsius into liquid water at 60 degrees Celsius. So now we got three things going on. Well, what three things are they? Well, we know that steam comes to existence from boiling water at 100 degrees Celsius. Now we've superheated it to 120 degrees, so it's got to drop back down before it changes back into water, a process we call condensation. So the first heat change is the loss of heat to change it from 120 degrees to 100 degrees. Then when it reaches 100 degrees, the steam at 100 degrees then is going to be changed from gas to liquid water. So that's where the latent heat comes in. That LV is the latent heat of vaporization, and that's that quantity right there. Okay? Now, the fact that this is cooling down instead of heating up actually makes that a negative value, because we're going in the opposite direction of vaporization. So we can technically call that L sub condensation, but we rely our value on L of the opposite process, which is vaporization, but we have to remember to change the sign when that takes place. And then the last part, now that we have water created at 100 degrees Celsius, that's going to cool down to 60 degrees Celsius. So that's going to involve a heat capacity of liquid water of 4186. All right, so three things. Heat change, and it's going to be negative because it's exothermic. It's going to drop down, and we'll see how that works with the change in temperature. But the first heat change is going to involve this C value. The second heat change is going to involve this LV value. And the third heat change is going to involve this C value right here. So that means then we have the total heat is going to be equal to the heat of H1 plus H2 plus H3, where this is the decreased temperature of steam. This is the phase change here from steam to liquid water. And this is going to be the decreased temperature of the water from 100 to 60 degrees. So we have to calculate all three of these. So let's do H1 to begin with. If I can keep following my paper properly, that would be really nice. So since this is a heat change, this is going to be MC delta T. And again, we're going to change our grams to kilograms. And if we go ahead and do that offside here, we can just put down 0.125 kilograms. Because again, there's 1,000 grams in a kilogram. So 0.125 kilograms times the heat capacity of water, so the liquid, which is 4186 joules per kilogram degrees Celsius, times the change in temperature. Now the change in temperature again is heat final minus heat initial. The final temperature is going to end up being at 100 degrees, and the initial temperature was 120 degrees. So as you can see, that's going to give us our negative value. This indeed is an exothermic reaction, so this is what has to happen. We calculate this, punch it into our calculator, and we get negative 5.00 times 10 to the third joules. So that's H1. H2 now is going to be the phase change, and that's going to be MLV. Well, actually M negative LV, because we changed that to the negative sign, because it's going to be an exothermic direction here. The mass again is 0.125 kilograms. And again, we go back to up there, LV, we said a negative 2.26 times 10 to the 6th joules per kilogram. And then we just go ahead and calculate that nonsense out. And we get negative 2.83 times 10 to the 5th joules. Then the third change is, again, the drop in temperature. Now that we've changed steam over to liquid water, the water then begins to cool off. So we use the MC delta T again. Only now, this is the heat capacity of liquid water. This actually was steam, wasn't it? That's incorrect. So that's steam right there. And this is liquid water right here. Uh-oh, did I punch the wrong number there? I did. So that should have been 2,000 right there, not. That's 2,000, and that was, yes, that gave me the -5. So I put the wrong number there. Again, not looking at my paper too closely, and that cost me yet again, because I'm really good at that. So again, we got 0.125 kilograms times, now the heat capacity of water, 4186 joules per kilogram degrees Celsius, times, and then the heat change, or temperature change rather, the final temperature is 60, and the initial temperature is 100 degrees Celsius. And when we punch that into our calculator, we get a value of negative 2.09 times 10 to the 4th joules. So now we have the three stages and the total amount of heat that's going to be released. H total. H1 we said is negative 5.00 times 10 to the 3rd joules. H2 was negative 2.83 times 10 to the 5th joules. And H3 is negative 2.09 times 10 to the 4th joules. And if you put all that in your calculator, you should end up with negative 3.09 times 10 to the 5th joules. So, identify the number of phases or number of heat changes. One will involve a phase change, one or two will involve a change in temperature of an established phase. So, you have 4 practice problems. These are much more math intensive, so it'll take you quite a while longer to do these than it did the previous assignment, but you know, that's the yin yang of life. Hey, have some fun.